Okay, our topic for today is about simple curve. So simple curve, it's been used for having a smooth transition when it comes to the corners of the highway intersecting together. So for example, you have two roads. So I'm just telling it for like few times. If you have two roads intersecting, so it's better if you will use a curve like this for a smooth flow of traffic. So that's the main reason why we are using curve instead of this kantuhan intersection. So in actuality, maybe you will be asking yourself which one is the simple curve, or how are you going to understand which one is simple curve or not, if it's a simple curve or not. So say for example, this is a good example of simple curve. So I'll have a layout, and this will be your curve. Okay, so that's a simple curve. So since this one has another curve here, so maybe you can consider that as reverse curve or compound curve, but maybe we'll discuss it in the future. So let's focus more on the simple curve. So simple curve is a very simple factor to consider when designing highway. So it's it's like you have this one is radius, and this one is your curve. Okay, so this is your curve, meaning to say this is the center line of your highway. Okay, so if you have a radius, for sure you have this angle. What is too thick? Angle delta. So this is the length of your curve. Excuse this. Okay, so apart from that, you have the tangents. So we can consider those tangents. These are your tangents. So let's consider this as tangent 1. So this tangent 2. Okay, so let's erase this kinda. Tangent 1 and tangent 2. So okay, so this is tangent 1 and this is tangent 2, and this one is the intersection. This is delta, this is also delta. So one more thing, this is the length of the curve, and if you add another element, the point where the tangency starts, it's called chord. It's called chord. So where it starts is called point of curvature, and this one is point of tangency. If this is delta, this must be delta all over 2. So that's one property of a circle. One more thing. Another element to be added is this one is perpendicular, similar to this one. So that's it. So the most common questions that the designers are asking is, what is the length of the curve, what is the length of the chord, what's the radius, what's the delta or the deflection angle. But unfortunately, in actuality, it's hard to lay out the length of curve that long. For example, the length of her curve is for example, the length of the curve is 200 meters. Yeah, it's easy on the paper if you'll say that's 200 meters, but in actuality 200 meters is very big one. And when you're using when you're working on paper, you will only have like some sort of radius here and radius here, and then you'll like get a French curve, then you'll connect this radius, and you will have the length of the curve, right? But in actuality, it will be very hard if you will have like one layout of 200 meters. So what the engineers are doing is they are doing it by segment, not by the entire. So engineers are doing this thing. So if this is your point of curvature, sorry, and if this is your point of tangency, what they are doing is they are dividing it. Okay, they are dividing it. Let's undo it. They're dividing it, so you will have different alpha. Let's consider 2, 3, 4, 5. Let's say so this one is your length of the curve. This is your radius. These are also radius, right? Because it's a segment of circle. And it's your chord. Okay, so that's how they are doing that. For example, they're having different stations. For example, this is your point of curvature. Then let's say this one is station A, this one is station B, this one is station C, this one is station D, and this one is the point of tangency. So it depends on the station. It depends on the stationing and how big is it. So mostly or as per standard, distance per station when you are using metric and when you're using English. I'm telling about system. So distance per station is 20 meters when metric and 100 feet when English. So mean to say, say for example, first station will be, for example, 1 plus 0, 0. Then second station will be 1 plus 0, 20. So we're dealing with meters. Third station will be 1 plus 0, 40. So if you will check, the difference between station is 20 meters. When you're considering English system, so the first station will be 1 plus 100 feet. Next station will be 1 plus 200 feet. The next station will be 1 plus 300 feet. So it depends on the standard that you are following, but here in the Philippines we're using meters instead of feet. So if you can see, the difference between this station is 100 feet. So when solving for the radius of the curve using a simple solving the radius of a curve for a simple curve, the engineers are implementing two types of methods that they are using. One is the chord method and the one is the arc method. So let's check. So question: how to solve the radius of the curve? If you'll remember, in order for you to solve the radius of the curve in a simple curve, so if you'll remember this formula, r is equals to v squared all over g e plus mu. So this one is the minimum radius of the curve. But what if we will use the concept of, so let's say this is letter A, concept of simple curve. Say B.1 is chord basis or method. So for the engineers, when you have a simple curve, so the engineers will likely to connect the radiuses by using chords. Instead of, radii, using chord. To determine the radius of the simple curve. So given that situation, this will be your, I think, while this is your R, and this one is 90 degrees. And let's consider this as deflection angle. So if you will amplify it, we'll have a situation like this one. This one is your radius. This is your deflection angle. Sorry. For example, this one is your first point of curvature. Say this is your station A. So if it's your D, and this is also your radius, so you take the half. Sorry. Okay. And if the total distance of this chord is 20, so you consider this as your station PC in station A. So that will be similar to this one. Let's just amplify. This will be D all over 2. This will be 10 all over 2. And this will be your R. So how are you going to solve for R? So that's so. Sine theta is equals to opposite all over hypotenuse. So sine D all over 2 is equal to it's 20 all over 2. Opposite, so that's 10 all over R. So R will be 10 all over sine D all over 2. So that's your first formula for chord basis on determining the minimum radius of a simple curve. Next is the arc basis. Okay, when you say arc basis, they are using arc instead of a chord or straight line. So let's say this one is PC and this is your station A. This one is 20 meters, the length of the arc. And if this one is your radius, and this one is your radius, and this one is your deflection angle, so it's easy, like S is equals to R theta. S is equals to 20 meters, so that's 20 meters is equals to R times D. So but you cannot multiply directly R to a degree, so it will become 20 meter is equal to R times D, which in degrees, pi all over 180, converted into radian. So R will be 20 meters all over pi D all over 180. So that's it. So you can like have this formula, or R is equal to 20 times 180 all over pi D. So you'll have a formula of 20 times 180 is 360 all over pi D, or 360 divide 3.14 16 114.5913 all over D. So it's up to you which one is formula is you're gonna use. This is metric. If you want to use English, you just need to substitute it by 100 feet. So R will be 1/8 times 100 feet. Sorry, R will be 100 feet Now it's 180 all over pi t. So this one is English system. So I hope you learned something from me today when it comes to the solving of the radius of the curve using arc basis and chord basis. So on the next topic, we will discuss the elements of a simple curve. Maybe this video is too long, so check for the next video, part 2 of the simple curve. Thank you.